So just as a quick reminder, so what we had started looking at yesterday was we had looked at volume and capacity, and we just looked at prisms. You know, that's like rectangular prisms, triangular prisms, and we looked at cylinders. And remember, volume was how much space is in here, like how much actual like empty space is in here, and capacity was actually how much can it hold. It can hold, you know, like this is a 4 gallon, it's 18.9 liter jug, it can hold that many liters, but there's still a lot of empty space in here. So you can measure them differently, essentially. That is going to come into play again today. Most of what we had done was if we wanted to find the volume of something, all we did was we figured out that the area of the base, and as a quick reminder, the base of this thing was a centimeter or a circle. Oh, yeah. So the base of this is a circle. So once you figure out the area of this circle, then it's just times it by the height. See how many times it can stack up. That's not going to work as well today, specifically because we're going to be dealing with objects that just don't go kind of straight up in a nice same pattern as before. If you think about a soup can, the soup can is just like it's a perfect cylinder. But now we're going to be dealing with things that aren't perfect cylinders. So there's going to be some more formulas instead today. Where in this case, instead of trying to figure out, okay, what shape is it? What's the formula for that again? It's really going to be, it's a pyramid. This is the formula for it. So these are not things you're going to have to memorize. These are things you're going to be given. Oh, where am I? Here we go. So let's jump into this. I'll move that. Okay, so first off, we're going to look at spheres. So spheres, that's just a ball, right? That's just a ball. It's a round ball. This is the formula for that. I'm going to have you guys box that or highlight it, whichever you prefer. But the formula for this here is it's 4/3. It's a fraction times pi times radius cubed. You notice there's a 3 there. I think it's a little, is it a little grayed out for you guys on your paper?
Yeah.
I probably could have printed that a little bit. Are you guys able to read it at least though on your paper? Yeah. Okay. So sorry, I'll make that darker next time. But so this right here is the formula to find the volume of a sphere. Is that one right there? So let's go try that one as an example here. So let's actually scroll down a page to this next one here. So so what we have here is we have a ball with a diameter of 1.2 meters. And so what we want to know here is we want to be able to figure out its volume. So immediately I'm dealing with the volume of a sphere. So I know I'm going to have to use that formula. Now, the other thing as well is we notice that we also have capacity. Whenever we have capacity, what I recommend you guys do is turn your stuff into centimeters. So instead of 1.2 meters, I'm going to use 120 centimeters because that's what that is. Because all I did was I times that by 100, right? Because there's 100 centimeters in a meter. So I'm going to actually use a new figure. So it's really important. Let's read the question in advance. Don't just immediately go and solve it because you have to basically do that step all over again otherwise. So whenever I'm dealing with a volume, I always need to think, what is the formula I need to do? And if we remember, the formula here, it's exactly what's up there that we boxed earlier. So the volume, V, is equal to, oops, it's 4/3 as a fraction. I'll put the line in there in a second. And then it's times pi times the radius cubed. So just like that. Those time symbols don't exist in your actual formula. That's because they're invisible, right? The only reason I'm doing those X's there is to show that you're multiplying those things together. Okay, so all I now need to figure out is what the radius of this is. So what's my radius of the sphere?
60.
It's 60, right? Because remember, a diameter is the line that goes all the way through.
the circle, but I only care about the radius of it, that blue line. I only care about the radius. So, and the radius is always going to be half of it. So I'm just going to take 120. You don't need to write this down if you don't want, but I'm just taking 120. I'm cutting it in half, and I know that it's 60 centimeters now. So now I'm just going to quickly fill that in. So it's the same formula. Volume is equal to 4/3 times pi times, now not radius cubed, it's going to be 60 cubic centimeters, 60 cubed centimeters. So now all I have to do is I have to take that and punch it in my calculator. Remember, the math itself is not hard. It's the setting it up to be successful. That's the hard part of the unit. Because the calculator does all the heavy work for you. So 4/3 times pi times 60. Now you might be wondering, well, where's the cubed button? We have that little square button, but the cubed one, it doesn't quite work. And yes, you could do times 60 times 60 times 60. I'm a big fan of write it exactly how it's shown on your paper. So what I'm going to do is I'm going to show you that. So there's this little button here. It's the left side. You see it's that Y with a little X above it. That's how we're going to turn that into a cube. So that's saying that, hey, if I click this, I want to take this 60 and I want to make a little power there. I want to put an exponent up there. And if I'm cubing something, it's a 3.
We also have RCL. If you do a second function of RCL, there's X3 there. Well,
oh yeah, you can second function that too. You could do that too. Yeah. I never saw that one. Probably would have been easier, but okay, we're committed now. There also is the X cubed button, I guess, with the second function on the RCL. It's above your 8. Either one of these will work. But was everyone able to find that? Was everyone able to successfully cube it? Okay, if that's the case, all you now do is you press enter, you change it, and I can see it's 904,778. So 904,778.68. It's a really big number, and I'm going to explain how that makes sense here shortly. But so it's 904,778 cubic centimeters. It's a really big ball. So the next question it's asking us though is, well, what's the capacity? I'm just going to scroll up for a second. I'll come back down. But if you remember, when we're thinking about capacity, we're thinking about how much liquid can it hold. Liters, gallons, milliliters. Those are the measurements we're using whenever we deal with capacity. And we have one universal law when it comes to this, which is that we know that 1,000 centimeters cubed, this is on page 38 or page 40 we looked at yesterday. 1,000 cubic centimeters is the same as 1 liter. When I have 1,000 cubic centimeters in space, that's a liter in liquid. You do not need to memorize that. So I'm just going to quickly put that in. I put down what I know. I know that 1,000 cubic centimeters is equal to 1 liter. Which kind of raises the question, well, what if I have a 904 and some thousand of these?
Divide by 1,000.
Yeah, you could just divide it by 1,000, right? If I want to know how many liters that is, all I need to do is just take this number, divide it by 1,000. You could also do that little arrow thing, like, oh, 1,000 times some magical number will give me this, and that'll work for the liters as well. Either's going to work. I'm just going to divide it by 1,000. 904,778.68 divided by 1,000. I'm going to see it's 904. I'm just going to round it to 904.78 liters. So if I divide this by 1,000, it's going to be 904.78 liters. Now, had we not converted this, had we not converted these meters into centimeters, if I would have kept with that 1.2 meters, I won't show you all the math, but if I would have done 4/3 times pi times 0.6 meters squared, what I eventually would have gotten was I would have got, it'd be 0.91 cubic meters. Was what I eventually would have gotten from this. And so we're going to potentially look at how this works. Before, if I'm turning a meter into a centimeters, if I'm turning 5 meters into centimeters, you just times it by 100. It's a little different once we work with cubes and squares and stuff like that, which we'll get to today. So, but that's spherical volume and capacity. So let's try out another one here. So that's one of our shapes. We've already done spheres. Now there's 3 more shapes we're going to look at today. No, there's 2 more shapes that we're going to look at. Yeah, just 2 more. So that's one of the shapes is we've looked at spheres. Those are just balls. The next one we're going to look at is we're going to look at a pyramid. We're going to look at a pyramid. So I just want you to give that a quick underline here. So this is on that same page. So the volume of a pyramid is calculated with this formula here. I'm going to zoom in a little bit. So the volume of a pyramid is calculated with this formula here. You might need to rewrite this. I don't know how big this is on your screen, but that little A there, the thing you can see beside that is the base. So that is where that from what we looked at yesterday still does come into play, because you can have pyramids with square bottoms and you can have pyramids with rectangular bottoms. So there are differences there. You can also have pyramids with like 5 and 6-sided bottoms. We're never going to like touch that, but like they exist. You can have pyramids with different shaped bases. That's why that same formula from yesterday comes back. But when you see this A, that little text there, again, I don't know how visible it is on your guys' page, is a base. Almost all the things that we're going to look at are going to be rectangular. So either a square or a rectangle base. In fact, all the ones we're going to look at, I will not test you on a different pyramid, are going to have a rectangle, and the area of a rectangle is just length times width. So this bottom formula here is probably going to be the one you're going to use for everything. All right. So let's try out a pyramid. So I'm just going to go down to the next page here. So first off, what shape do I have on the base here? I'm just going to color in red. So if we're looking at the base of this pyramid, oh, that's not a good line. So what shape is this one here? Sorry? It's a rectangle. Yeah, it's a rectangle, right? And again, if your first thing is you like, well, I think it might be a square. I mean, well, squares are rectangles, so whenever in doubt, just be like, it's a rectangle. You'll always be right then. So I know it's a rectangle. It's like, oh, it's a rectangular prism. Well, first off, I'm dealing with a pyramid. I'm dealing with a pyramid. It wants us to find the volume of the pyramid and also the capacity. So, oh, I want to find capacity. Are my measurements in centimeters? Yes, perfect. So I don't need to convert to anything. So if I want to find the volume of a pyramid, well, I know that it's this formula up here. And it's a rectangular pyramid, so I'm going to use this one right here. Volume is a third times length times width times height. So I'm going to quickly just punch that in here. So volume is going to be equal to 1/3 times length times width times height. Again, those little X's are coming. That's just showing that I'm multiplying it. It's just taking that invisible part and making it visible. So now all I have to do is I just have to punch those figures in, right? So volume is equal to 1/3. So what's my length of my pyramid?
18.
Yeah, we'll go with 18. 15 is also fine, but so 18 centimeters times what's my width? 15 centimeters, that's my base. Ooh. And my height of it is 25. And again, this is really important. Your height is the line that goes all the way up, right? 25 is the pure height, straight up. This like the actual length of the triangle in the pyramid, that is not the height you need for the volume. That is not the height you need for the volume. So it's just the third times 18 times 15 times 25. All I had to identify that, hey, it's a pyramid, it's a rectangle on the base, this formula, plug the numbers in and punch it in your calculator. Oops. So if I do that, so the volume is equal to, so I always recommend use your fraction button. I think it keeps things nice and easy. So 1/3 times 18 times 15 times 25. 2,250. So volume is 2,250 cubic centimeters. That's a final answer. I'm going to circle it. Am I done? No, I'm not done. I've done one part of what the question's asking us. The reason so before we used to break it down into question 2A, 2B, 2C, we're going to start to try and get away from that now. The questions are going to be crafted in ways that get away from that. Because it's going to be a really important skill to have. You are going to be given questions like that. So it's important to read the question fully before we do anything. So I have the volume. Now I need to do the capacity. Do I have everything in centimeters? Yes, I do. So now I can work on capacity. So remember, you do not need to write this down, but to give you a reference here, capacity is it's turning centimeters, cubic centimeters into usually liters, right? So capacity is turning cubic centimeters into liters. And I know this is a rule, this is just a universal law, is that they've said that 1,000 centimeters cubed is equal to 1 liter. So I'm always just going to write that in just because I know it. And again, you can do this one of two ways. So you can do this one of two ways. You can either use that, what's the magic number here? Just like those ratios. Well, 1,000 times something is going to give me that. You can either do that, or you can take this number, 2,250, and you can divide it by 100. Either one of those is going to give you the same answer. And I can see that the actual answer here is going to be 2.25 liters. Oh, it would be 1,000. Thank you. Yep. 2.25 liters would be my answer. Okay. So again, a lot of the stuff, what we're doing is identifying what's the shape I have. Let's set myself up for success. And then it's just plugging in the formula and solving it. Now, this next question here is asking us, in this case, just the volume of the pyramid. The second I don't have to deal with capacity, I don't see anything below it that asks for capacity of this pyramid. I don't need to convert it. It's already in centimeters though. So I'm gonna just like power through this. So what's my formula to find the volume of a pyramid? I can see it has a rectangular base.
1/3 times width times height.
Yeah, I'm gonna do this instead of 1/3. I'm gonna do that little slash just to save space. That technically means 1/3. That 1/3. I recommend you guys. Actually, no. I'll just keep it consistent. I've been doing it the whole time. I'll just do that. There we go. I'll just keep it consistent. There we go. So it's a rectangular pyramid. I know that that's going to be 1/3 times length times width times height. My question for you is, do I have a height?
No.
I do not. I have a number that looks like a height. It is meant to deceive us. It is a trap question. I need the height. The height is the one that goes from the center of the pyramid all the way to the tip of the pyramid. I need that red line here. How can I find that? Well, if I look here, what I actually have is I have a right triangle. Yeah, I have two sides of a triangle. I need to use two sides to find a third side. So what I need to do is I need to use Pythagoras to find the height. I have the right formula, but I don't have the right numbers. If you put 22 instead of h here, it would technically be the wrong number. So I need to use Pythagoras. How do I do Pythagoras again? It's a squared plus b squared equals c squared. So what's my c squared in this case?
Would be 22.
It would be 22 because my right triangle here, this is my hypotenuse. So I already know what the c squared is. So it's 22 squared. What about this bottom line here? What's that? What's the length of this line, this red line?
Would be 26.
So it's not 26. 26 is the length of the whole thing. But I only care about the length of this part of it, which looks like it's about half. So probably 13. Yeah. So that's where I'm getting 13 from, is I've just taken this 26 and I've cut it in half. So 13 squared plus b squared equals 22 squared. So all I'm going to quickly do is I'm just going to square those out. 13 squared on my calculator will give me 169 plus b squared equals, what's 22 squared? 22 squared. I don't even have that one memorized. 484. Again, all that stuff we've learned in the past, we are going to need it. It comes back. I forgot to put centimeters here, but I'm too far gone at this point. I messed up at the very beginning. So I got 169 by squaring 13. I got 484 by squaring 22. So now what I need to do is, my ultimate goal here is I'm trying to get it so that it's going to tell me, hey, the answer is something. That's what it wants. That's what I want. The problem is I have two things in the way. Can anyone guess what they are? There are two things I need to get rid of on this equation to figure out just tell me what b is. So the 169 is one of them. What's the other one?
And 484.
Well, the 484 is already on one side by itself, so it's not that one. It's something on the left side here. and the square. These are the two things I need to get rid of. If I get rid of those two things, all of a sudden I am able to words. I'm able to get my answer. So what I'm going to do is I'm going to start doing the opposite stuff. So I need to get rid of either this 169 or this squared first. And so if you guys, do you guys learn it as bed mass or head mass? Bed mass? Yeah, bed mass, brackets, exponents, or no. Yeah, brackets, exponents, multiplication, division, and addition and subtraction. You do it the opposite way around. So the opposite way, addition, subtraction, like whatever's at the end of that, I need to get rid of this 169 and this plus first. So what's the opposite of adding 169? Just taking it away. So all I'm going to do is I'm going to take it away from both sides. And so what's going to happen? These are going to cancel out, and I'm just going to be left with b squared on the one side. On the left side, it's just b squared. On the right side, it's going to be 484 minus 169, which is 315. But I've still got this squared here. So now that's the only thing I have left remaining. I want to figure out what just b is. So I need to do the opposite of this. So it's squaring. So what's the opposite of taking the square or something? Square rooting. So I need to square root the whole thing. So if I do that, these are going to cancel out. And I'm just being left with the square root of 315, which is 17.75. That was a bad 7. Let me fix that. That's an important number. I'm going to underline it. But now what I have in my triangle is I now know what the true height of it all is. I'm just going to erase all my things here. So in my triangle, I now know that this height is it's 17.75, as I've discovered. And now I'm equipped to do exactly what I said it was at the very top. Just like before, I wrote my formula at the very top. I know what I have to do. Always write your equation at the top. I now have my length. I now have my width. I now have my height. So all I'm going to do is I'm just going to punch that in over here on the very, very bottom. So volume is equal to a third. We'll zoom in. So a third. What's my length? 26. What's my width? 18. 26 centimeters. Oh my, I'm just going to type it. Times 26 centimeters times 18 centimeters. And now what's my true height? 17.75 centimeters. And so if I punch that all into a calculator, I'm going to eventually get a final answer of, let's find out. Oops, times 26 times 18. Times 2,769. 2769 centimeters. It's volume, so it's cubed. Don't do all that work to forget to put the cubed part at the end of it. Don't put a square. And I'm going to circle it because it's my final answer. And there's a lot on this page. All right, and so we got one final one here. The last one we're going to be doing is we're going to be doing a cone. And you might be looking up here at your notes, and you might be like, well, where's the cone formula? That's because I forgot. Sorry. So the last thing we're going to do here is we're going to go to a cone. So I'm going to get you guys to go up to page 49. And I'm just going to get you to quickly put formula of a cone. Just in all that white space on the right side. I apologize. I forgot to write it down. So formula of a cone. Is going to be this. It's 1/3 times pi times the radius squared times height. Times pi times the radius squared times height. So I'm just going to box that because we always know we're going to come back to this. Like I said, you do not need to memorize these. You will always be given these. Now you're going to be noticing here, this is still the height. If we think back to the area of a cone, back in unit 2.2, we wanted the slant. Now I just care about the height. So we only ever care about the slant when we deal with area. When we deal with volume, we want the height of stuff. Up here, oh, that's a 2. That's pi, that's r squared. Yeah, sorry, I know it's kind of small. So 1/3 times pi times r squared times height. So now that I have that, I'm going to go back down to our final question here, which is basically, I have a paper cup in the shape of a cone. It has a radius of 3.2 centimeters and a height of 6 centimeters. It wants to know how much water the cup can hold. So this is kind of a trick question. How much water can the cup hold? Is this a volume or a capacity question? It's a capacity question. But what do I need to find the capacity of something? I need the volume. So I have to find the volume, but I need to use that to answer what the question's asking, which is a capacity question. So this is a capacity question. At its core, that's what it is. If you found the volume of this cone, you'd be so close. You'd be almost there. So I'm just going to quickly do a diagram here of the cone. So we've all seen these. You guys have seen these paper cups like this? Probably, like I always see them at like dentist's office and stuff like that. So that's what it's saying is, hey, I have a paper cup like this. And so what it's saying is, so first off, I can see I have the radius. I don't have a diameter, I have a radius. So the radius here is 3.2 centimeters. I'm just going to write that 3.2 in there. And then the height. The height of it is 6. I'm going to make this a little bit neater. Remember, height is the thing that goes straight down. This little thing right here, this line, is the slant. I don't care about the slant for volume. I'm labeling it just to show you. That's the slant. I do not care about it. So cool. And now all I need to do is I just need to take that formula that I just made and pop it in here. So the volume of a cone is equal to 1/3 times pi times radius squared times height. So 1/3 times pi times radius squared times height. I got some email really quick. Okay, so I have my formula. Now I have to do is plug it in. I can see I have a radius. I can see I have the height. So I have all the steps I need here to do this. So I'm just going to quickly rewrite that, but with everything that I know put in. So it's still the 1/3. It's still a pi. 1/3, still pi. But it's still times by the radius squared. What's the radius? 3.2 squared and then centimeters, not centimeters squared, 3.2 squared and then centimeters, because that's showing that I need to square it. Some people like using a bracket. And what's the height? 6 centimeters. Remember, I only care about the true height. Oh, no, that's the wrong. I literally just said it and I did it. All right, I have everything filled out. Now I just let the calculator do the heavy lifting. So 1/3 times pi times 3.2 squared. That's going to be a really common mistake. People are going to forget the square in their calculator. Times 6. And if you do that, you should get 64.34. 64.34 centimeters. And it's volume, so we always measure that in cubes. And again, the biggest mistake you're going to make here is, cool, I'm done. I found the volume. It is not a volume question. It is a capacity one, which means I want to know how much water this can hold. How can I turn centimeters cubed into liters? I can just divide it by 1,000. So I'm going to take that 64.34. I'm just gonna type it. I'm going to take 64.34 and I'm going to divide it by 1,000. And if I do that, I should get 0.0. Now it's 0.63. 6434 liters. That's kind of a hard number. So I would accept this as an answer. I would accept 0.06 liters. I'm going to convert this though into milliliters. Anyone know how many milliliters are in a liter? 1,000. So I'm just going to convert this into milliliters, which means I'm just going to times this by 1,000 again, which is just going to be 1, 2, 3, 4. No. Oh no, 1, 2, yeah, 2, 3. So I'm just going to turn this into 64.34 milliliters. I would accept either one of these answers. And again, you're going to get a formula sheet later, and it's going to show all of these different types of conversions. You're not going to need to memorize a lot of those facts at all. As long as you know how many centimeters are in a meter and vice versa, and how many millimeters are in a centimeter, you're probably okay. Okay, so what we're going to do is we're going to cut for a break here. When we come back for a break, we are going to do a concept check. As a reminder, it's not going to be volume stuff. We're going to do a concept check on lesson 1 and lesson 2 only. So you give you your 15 minutes here. When we come back, we'll do a concept check on that, and then you'll have some time to practice some of this stuff.